For this last example, we're going to write the geometric, this is a geometric power series centered at x equals 2. So this one's a little tougher. Maclaurin are easy. Centering at 0 is easy. What I'm going to do first is look at my goal, which is a sub 1 over 1 minus r. And the first thing I notice is that my 1 is on the right and the 2x is on the left, and I'd like to switch them. So I'm going to change this to a 15 over negative 1 plus 2x. My next issue is that it needs to be centered at x equals 2, which means I need x minus 2 in my problem. So don't work too hard at this, just put it in. It's 15 over negative 1 plus 2 times x minus 2. Now these are not equivalent, but that's okay, I'm going to fix it. If I distribute this, this is negative 1 plus 2x minus 4 in my problem right now. So I need it to be negative 1 plus 2x, but I changed it by subtracting 4. So all I have to do is add 4 back. So I'm going to add another 4, but I'm going to combine this 4 with this negative 1. So this is 15, and then, I don't know why I wrote 5, it's 4. So 4 and negative 1 is a 3 plus 2 times x minus 2. And if you distribute the denominator now, you'll see we are where we need to be. It is 3 plus 2x minus 4. The 3 and the negative 4 combine to make the negative 1. So this and this are equivalent. My next issue is that I need this to be a 1. And that's pretty simple. I'm going to multiply this by a 1/3 over 1/3, a clever form of 1. So 15 times 1/3 is 5. This will be a 1 plus 2/3 times x minus 2. My last issue is that I need this to be a minus, and that's the easiest to fix. This is 5 over 1 minus a negative 2/3 x minus 2. And this is equivalent to my original f of x. So now I know my a sub 1 is 5. And my r, my common ratio, is a negative 2/3 times x minus 2. So when I write out my series, first term is 5. I'm going to multiply this by a negative 2/3, so negative 10/3 times x minus 2. Then I'm going to multiply this one by a negative 2/3, so plus 20/9 x minus 2 squared. Do it again, so minus 40/27 x minus 2 to the third, plus, put my ellipses on, and then remember this is geometric. So this is going to be the sum from n equals 0 to infinity. And I know my common ratio. I know I'm multiplying by negative 2/3 x minus 2, and then I have to figure out the power on that. It's not in my 0th term. I'm just going to put that as the n. So when n equals 0, that's a 0, and it's all 1. So times 5. This is my sum of my series, and it will converge when the absolute value of my r is less than 1. So it'll converge when the absolute value of negative 2/3, now I'm doing absolute value so I don't need the negative 1 there, 2/3 times x minus 2 is less than 1. I can take the 2/3 out, so 2/3 times the absolute value of x minus 2 is less than 1. If we keep working this, I'm going to move the 2/3 to the other side, multiplied by the reciprocal, so the absolute value of x minus 2 is less than 3/2. So on a number line, again, my distance from 0 can be a positive 3/2 or a negative 3/2, and my x minus 2 has to fit in between. So my inequality is negative 3/2 less than x minus 2 is less than 3/2. I can add 2 to each side. Now negative 1/2 plus 2 is 1/2. Less than x, less than, I'm going to add 2, so 1/2 plus 2 is 3/2 or 7/2. And I have my interval of convergence, and I have my series.